Hello students, welcome to the model paper for your final exam. First, please subscribe to the channel to avail the opportunity of getting a free PDF of the mentioned model paper. Now, the question paper has been divided into a 70 mark paper and you have 5 units to study. Beginning, we will revise all the 5 units quickly, memorize a few constants which we will be requiring to solve the numerical. In case those constants have not been mentioned in the question paper, we should be remembering them, and then quickly we will solve one model paper of 70 mark for the final exam. Let us begin. Our first unit is quantum mechanics. What we should remember is the value of numerical value of Planck's constant H equal to 6.63 into 10 to the power of minus 34 joule second. Rest mass of electron 9.1 into 10 to the power of minus 31 kg. Velocity of light 3 into 10 to the power of 8 meter per second. 1 electron volt equal to 1.6 into 10 to the power of minus 19 joule, and mass of electron 1.675 into 10 to the power of minus 27 kg. Now the formulas. Stephen's law is E is equal to sigma T to the power of 4. Wayne's displacement law, lambda m into T is equal to a constant. Average energy of Planck's oscillator, at times they give the to find the derivation of this formula. So E is equal to h mu upon e to the power of h mu by kt minus 1, where k is Boltzmann constant. The most important part of quantum mechanics is de Broglie wavelength. You can expect a question every year on de Broglie wavelength, either a numerical or a derivation. All you can solve with the help of the formula lambda equal to h upon p, where p is momentum, h is Planck's constant. Other ways of writing this formula is lambda equal to h upon under root 2 me, lambda equal to h upon under root 2 mq v, where q is charge, v is potential difference, or lambda equal to 12.28 under root v, and here lambda comes in angstrom. The relation between wave velocity and group velocity is wave velocity into group velocity is equal to square of velocity of light. Every year, a question in section C is asked where you are expected to derive the Schrödinger wave equation. The Schrödinger wave equation is minus h bar square upon 2m del square plus v whole into wave function is equal to I h bar del wave function upon del t. The other form is del 2 phi by del x2 plus 2m upon h bar square into E minus v is equal to 0. The normalized form of wave function, that is the condition for it to be acceptable, is that mod of wave square should be equal to 1. And for particle in one-dimensional well, the wave function is given by under root 2 upon L sine n pi x by L into n, where n is 1, 2, 3, etc. Compton shift is given by del lambda is equal to h upon m naught c into 1 minus cos phi, where h upon m naught c is also known as Compton wavelength. The eigenvalues of energy are En is equal to n square h square upon 8ml square. Davison-Germer experiment was conducted to confirm the de Broglie concept of matter waves. Electromagnetic theory, you should remember Gauss law of magnetostatics, divergence B equal to 0, Gauss law of electrostatics, divergence D equal to rho, where D is displacement current, rho is charge. Faraday's law of electromagnetic induction, del cross E is equal to minus del B by del T, where E is electric field intensity and B is magnetic field intensity. Ampere's circuital law, curl H is equal to current density J. Equation of continuity, divergence J plus del rho by del T is equal to 0. Now, Maxwell's equations, the first equation gives differential form of Gauss law in electrostatics, that is divergence D equal to rho. Second equation gives Gauss law in magnetostatics, divergence B equal to 0. Third equation gives Gauss law in electromagnetic induction, that is del cross E equal to minus del B by del T. The fourth equation gives modified form of Ampere's circuital law, that is del cross H equal to J plus del D by del T. Now, if we are asked to write Maxwell's equation in free space, this question can be asked in section A. Then free space means no charges present, rho equal to 0, and obviously current density J equal to 0. Hence, Maxwell's equations in free space become del dot D equal to 0, del dot B equal to 0, del dot E equal to minus del B by del T, and del cross H equal to del D by del T. Now, Poynting theorem is again one of the very important topics of electromagnetic theory. This equation summarizes Poynting theorem mathematically, where it states that integral V J dot E dV equal to del by del T, integral of E dot D plus H dot B divided by 2 plus integral of E cross H, where E cross H is Poynting vector, E dot D plus H dot B means energy due to electric field and energy due to magnetic field. Poynting vector S is equal to E cross H. Radiation pressure is given by force upon area. Skin depth is equal to 1 upon attenuation constant, and mathematically under root 2 upon omega mu sigma, or 1 upon pi f mu sigma. And mathematically, for solving equations or numericals in Poynting theorem, I should remember S is equal to E cross H and E upon H is equal to 377. Now, the new heading that has been added in my syllabus is electromagnetic wave in conducting media. So, the permittivity is psi, permeability is mu, conductivity is rho, and conductivity is sigma, and charge density rho should be equal to 0 for conducting media. So when you put rho equal to 0, the Maxwell's equations in conducting media become del dot E equal to 0, del dot H equal to 0, del cross E equal to minus mu del H by del T, and del cross H equal to sigma E plus epsilon del E by del T. Since this heading is new, a very common question is that prove that electromagnetic waves through a conducting or dielectric medium are in the form of complex form. That means they are consisting of imaginary part and real part. Alpha will be the attenuation constant of the wave and beta the phase constant. Then a uniform plane wave that propagates in the forward z direction with phase constant beta, but which for positive alpha loses amplitude with increasing z, is given by Ex is equal to E naught E to the power of minus under root omega mu sigma divided by 2 E into e to the power of minus j under root omega mu sigma divided by 2. So we can see it is consisting of real part and imaginary part. That is, one is attenuation factor and the other is phase factor. For details, you can refer to my lecture series in the playlist. Wave is attenuated exponentially and velocity of wave propagation is given by frequency upon phase factor. Refractive index is given by velocity upon frequency. For wave optics unit, I should remember, especially while I am solving Newton ring questions, that 1 angstrom is equal to 10 to the power of minus 10 meter. Snell's law is mu equal to sin I upon sin R. I will require it for deriving the formula for path difference of thin films, wedge shape, and Newton's ring. Stokes' law states that when light is reflected from the surface of an optically denser medium, it will suffer a phase change of pi or a path difference of lambda by 2. Hence, total path difference in thin films is equal to 2 into mu t cos r plus minus lambda by 2 as per the direction of rays. And colors visible in reflected system will be complementary to the colors that are visible in the transmitted system, because I have two cases in my syllabus of interference in thin film due to reflected light and transmitted light. The same formula for wedge-shaped film becomes path difference where the wedge is inclined at an angle of theta. The path difference becomes 2 mu t cos r plus theta plus minus lambda by 2. In Newton rings theory, the center of the ring always satisfies the condition of minimum intensity, hence it is dark, unless and until dust particle or thin film is not introduced between that place. Constructive interference 2 mu t equal to 2n plus 1 into lambda by 2, where n is 0, 1, 2, etc. Destructive interference 2 mu t plus lambda by 2 equal to 2n plus 1 into lambda by 2, or 2 mu t is n lambda. And the very famous formula for Newton ring experiment and expecting a numerical for the same, lambda is equal to d square n plus p minus dn square upon 4pr, where dn plus p is the diameter of one ring and dn is the diameter of the ring, where I take the difference, suppose 20th ring and 16th ring, then p becomes equal to 20 minus 16 equal to 4. For diffraction, most important heading is intensity due to single slit. So, intensity is equal to a square into sine alpha by alpha whole square. Intensity due to n slit is equal to multiple of intensity due to single slit into intensity due to n slits. Then, for grating, E plus D, slit width plus opaque space into sine theta is equal to plus minus n lambda. D theta by D lambda is equal to 1 upon under root E plus D upon n square minus lambda square. And resolving power, lambda upon D lambda is equal to n into E plus D sine theta upon lambda. Laser and optical fiber, maximum angle sine theta is equal to under root n1 square minus n2 square upon na, where n1 and n2 are refractive index of core and cladding respectively. Refractive index of core is always greater than that of cladding. Numerical aperture is equal to under root n1 square minus n2 square. Population ratio, numerical can be expected from this formula. N2 upon N1 is equal to E to the power of minus E2 minus E1 divided by KT, where K is Boltzmann constant. Angular spread of laser beam del theta is equal to lambda upon D, where lambda is wavelength and D is diameter of the focusing lens. V number is equal to pi D upon lambda naught under root N1 square minus N2 square. Number of modes is equal to V square upon 2. Number of decimals, numerical is asked on this formula. Number of decibels is equal to 10 log base 10 pi upon p naught, where input upon output power. And Einstein's coefficients, relation between them is A21 equal to B21 8 pi h mu cube upon c cube. Superconductors and nanomaterials. Certain metals show the property. These two topics are theoretical. Numerical can come from superconductor. So superconductor, certain metals and alloys exhibit the property of superconductivity at very low temperature. The Meissner effect, the property of expulsion of magnetic field from the interior is of a superconductor is called Meissner effect. They show the property of dimagnetism. Critical temperature, critical magnetic field are the points where the material undergoes a transition from normal to superconducting state. Type 1 superconductors are soft. They follow complete Meissner effect, whereas type 2 are hard and follow incomplete Meissner effect. Then Josephson effect is when two superconductors are separated by a thin insulating layer, then you can expect a continuous current to flow through it. This formula, variation of critical magnetic field with temperature, you can get a numerical from here. So HC, that is critical field magnetic field, is equal to H naught magnetic field at 0 Kelvin into 1 minus T upon Tc square. Numerical can come from here. What are nanomaterials? Nanomaterials are those materials who have structured components with size less than 100 nanometer in one dimension. The degree of freedom is for bulk material 3D, quantum well 2D, quantum wire 1D, and quantum dot 0D. A basic look at the nanomaterials are quantum dot are 0-dimensional, wire is 1-dimensional, well is 2-dimensional, and the bulk ones are 3-dimensional. How are nanomaterials prepared in the laboratory? Two ways are there: bottom-up approach and top-down approach. So bottom-up means that synthesis begins with the atomic or molecular precursors, assembling them until the desired nanomaterials are obtained. So nanoscience is the study of structures and materials on the scale of nanometers. Quantum dot is quantum dot can be expected in section A, is a nanoparticle made of any semiconductor material such as silicon, etc. Top-down approach refers to slicing and bottom-up approach refers to the building up. Chemical vapor deposition, section C, either chemical vapor deposition technique or the sol gel technique can be asked. The applications are coating for windows, fillers for paint systems, nanomaterials can be used as catalysts, etc. Now, I have a 70-mark question paper in front of me. Let me see how and time given to me to solve the paper is 3 hours. Section A is consisting of 7 questions, 2 marks each. That means section A is of 14 marks, where the 5 units have been distributed as 2 questions or 1 question from each unit. Section B has 5 questions, 1 question from each unit, either a numerical or a lengthy derivation. And 7 marks are there for the 3 questions which I will choose out of these 5 questions. That means every unit, 1 question they have asked of 7 marks. Section C, they have given a choice out of the 3 parts. Each, again, section C is consisting of 5 questions. Each question belongs to 1 unit. Like section C, first question, all is quantum mechanics, but we have to take up only 1 part out of it, which we find comfortable. Since Davison-Germer has been added this year, it might be important, or we can be asked a Schrodinger equation numerical. Like this only, you look at section C, next question. It will be based on electromagnetic theory. I have to attempt only 1 part from here. Then wave optics, similarly laser and optical fiber, and last superconductor. So superconductor, I can expect one very famous question of Meissner effect of superconductivity and dimagnetism and zero resistivity, a very famous numerical on the formula Hc equal to H naught into 1 minus T upon Tc square, or one property of synthesis of nanomaterials, either the sol gel technique or the chemical vapor deposition technique. In my laser part, I can expect either helium neon laser or ruby laser, a simple numerical on optical fiber for numerical aperture, etc., or to calculate how this helium neon laser numerical. Then in the optics part, I can expect Newton ring, one numerical on any part, either with the grating formula or the Newton ring or wedge shape question. And electromagnetic theory, I can expect that since electromagnetic waves in conducting media, or a Maxwell's equation, or transverse nature of electromagnetic waves. In quantum, I should be expecting Davison-Germer experiment, Compton effect, and particle in one-dimensional well. So let me see. I think it is better if I start solving from section C. This will save my time and I can score more marks in the paper, because the paper is lengthy and I have to write the answers. Like section A, they are just 2-mark questions. So I should expect, like, if the question is determine the de Broglie wavelength of a photon. So I will write the formula lambda equal to h upon p. I will get 1 marks for it. For photon, p is equal to mc. I will get my other 2 marks. Physical significance of wave function, that it should be normalized, finite everywhere, continuous. What is displacement current, or the concept behind it? It is time varying magnetic field. Factors responsible for changing fringe width in wedge shape film, wavelength, distance between slits, and the slit separation. Diffraction pattern, when single slit experiment is there, I will use my formula to give the answer. Metastable states, where the atom stays for a longer time compared to the general states. Optical fiber is based on the principle of total internal reflection. Quantum dots are tiny particles or nanocrystals of a semiconducting material whose diameters lie in the range of 2 to 10 nanometers. If I am asked to derive an expression for Compton shift, I should be making this diagram, and you can refer to the playlist videos in detail to see how to derive the expression. Then EMT wave in free space means that the charge is 0. So all my Maxwell's equations for rho equal to 0 become in this form, and then I derive the same. Grating numerical, resolving power is equal to n into n, and lambda upon d lambda is equal to order of the spectra into number of lines on the grating. Optical fiber numerical, this is how I am going to solve it. Superconductor, Hc equal to H naught into 1 minus T upon Tc whole square. Then let me see what is there for section C. If it is particle in one-dimensional well, I will solve it in detail because I have to get 7 marks for the answer. Then Suppose it's a numerical on particle in one-dimensional well, then I will be using the equation and solving the same. Davis-Germer, it is used to confirm the wave nature of electrons and finalize the de Broglie wavelength of light, that the answer comes same. You can refer the playlists of quantum, then derive wave equation for electromagnetic wave in conducting media. I will use my Maxwell's equations, put the values there, rho equal to 0, and I will give the detail of how to derive my wave equation for conducting media. This way, any equation of Maxwell can be there. Electromagnetic waves are transverse in nature. Again, 7-mark derivation. So the answer again becomes lengthy. Newton's ring, how they are formed. I will have to show it with the help of a diagram, how they are formed. And then I will derive the expression for diameter of the rings using the property of circle. Likewise, numerical for the wedge-shaped film, in case it has been asked in the paper, I will use the formula after reading the numerical, what it is asking. Plane transmission grating, E plus D sine theta equal to n lambda. If a helium neon laser has been asked, I will make the diagram of helium neon laser. I will explain the same with the help of energy level diagram. It is superior to ruby laser. And if a numerical is there, then N2 upon N1 is equal to E to the power of minus E2 minus E1 divided by KT. Numerical aperture formula, under root N1 square minus N2 square. Superconductivity, Meissner effect, it expels magnetic lines of force from inside, behaves like a perfect diamagnetic, and if a numerical is there, it becomes all the more easy. One synthesis technique, either sol gel or chemical vapor deposition technique. You can request for the PDF of the same either through mail or WhatsApp. Thank you.